Hello friends, welcome to my channel. Let's have a look at problem 876, middle of the linked list. So in this video, we're going to share two formats of solutions. So the first one is a linear traversal and a counting solution. And the second one is a slow fast pointers solution, same as Leetcode 2095. So actually we come here from problem 2095. And this problem here is easy, but we think that so we shouldn't neglect the easy problems in order to build strong bases or foundations to attack harder problems. So with that said, let's first read through the statement and then analyze the problem and finally share the code. First, let's look at the statement. So given the height of a singly linked list, return the middle node of the linked list. So if there are two middle nodes, return the second middle node. So this sentence actually concerns or related to the length of the linked list. So for example, if it's even, so we're going to remove the corresponding correct ones required by the problem. For example, in example 2, 4 is what we want to return, right? So with that said, let's look at the two examples. So in example 1, so the length is odd. So the middle one is the node with value 3. So we're going to output this height. So the corresponding linked list output is given by 3, 4, 5. And in example 2, so the length is even. So the length is 6 here. So we're going to output 4. Because 6 divided by 2 is 3, the index 3 corresponding to this node with value 4. So the output will be a linked list with values 4, 5, 6 for their nodes. So let's also look at the constraint or additional assumptions for this problem. First is the number of nodes in the list is in the range 1 to 100. So the 100 actually is a small number, right? So the node value is in between 1 and 100. So this one, the second constraint or assumption, is not that essential for this problem or for our solutions. So now let's look at the two solutions we're going to practice. So the first one is a linear traversal and counting. So the second one is the standard slow faster pointers. So the procedure for the two solutions are as follows respectively. For the first method, we're going to find the length of the linked list, and then we're going to return the proper node by another traversal, but we stop at the correct index. So this is the method 1. So for method 2, the procedure is the following. So we're going to use slow and fast pointers, and then the slow is the node we want to return when the fast arrives at the end. So here the faster or the fast pointer moves twice as fast as the slow pointer. So that's the procedure for method 2. So with that said, actually we are ready to write the code. So let's first do method 1. So in this case, so we're going to first get the length of the linked list, and then we get the correct index. So basically locate the middle node index and then do traversal to get it. So for this, let's first initialize a variable called count, initially 0. So the count will be the length of the linked list or the number of nodes in the linked list, and then the current is the height, right? Then we're going to use a while loop to count the number of nodes in the linked list. So that's actually very standard. While current, so we're going to increment this count by 1, and then we're going to reset the current to be the next, right? So after this, so we can actually get the length or the number of nodes in the linked list. That's the count status, and then we're going to get the mid index. So the mid index is going to be count divided by 2. So here divide is integer division. So next we just need to do a while loop to find the correct index. So let's do something. Let's use some annotation. So here is step 1, find the length, hence the mid index. And secondly, what we want to do is that, so we find the node corresponding to the index above. So for this, let's initialize a variable called I, which is 0 at the very beginning, and the current pointer is height, and then we just need to use a while loop. While I is less than, so let's see, while point, which is not empty, not null, and then I is less than mid index. So if this is the case, so we're going to trying to put this one to be the next, and then increment I by 1. So at the end, after we exit this while loop, the thing we get for the point state is what we want to return. So we're going to return point or pointer. So that's a solution for this problem. Let's do a special case check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes the generic case. So now let's copy the function signature up to here, and then we'll mark this one as v1, right? So let's present another standard way for doing this kind of problem. That is the slow fast pointers method. So in this problem, our goal is to initialize 2 pointers. One moves slower and the other moves twice as fast as the slower one. Then when the faster one arrives at the end, the slow one is locating the node we are going to return. So for this, let's first initialize the fast, slow, initially to be the height. So here is actually a subtle detail. For this problem here, we initialize the fast and slow both starting at the height. In certain problems, it can be the case that the slow is the head and the fast can be the head next, or vice versa, depends on the problem needs. So here, also notice that so the number of nodes in the linked list is at least 1, right? So because this, so we can do the next for loop. So follow well this like this, while fast and fast next. So because here the fast is initially the head is not null, so we can consider the fast next, right? So that's a subtle point. And then once this done, so we can move slow to the slow next, and then we can move fast to fast next. Here again, because that's within this loop, the fast next is not null, so we can do fast next and next, right? So this way, actually, once we exit this while loop, actually we make the slow pointer pointing to the node we are going to return, no matter the length is even or odd due to our initialization. Then we're going to return slow. So in this problem, we just need to return the corresponding linked list height, so corresponding to the middle node. So let's do a special case check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes the generic cases. So I guess it's about it for this 2 solution format. Here is a remark. So this problem actually can be regarded as part of problem 2095, right? So it might be better. So we first solve this one and look at 2095, but here we take the reverse order. But with that said, I guess we convinced the main purpose, that is to demonstrate 2 standard ways of doing this kind of task in linked list. So that's it for this video. Thank you very much.